Good morning. Once again, I'm coming to you from the Crown Plaza, Fort Lauderdale Airport, Cruise Port at 455 State Road 84. And we are using the PDM methodology and it's the outputs, the medical outputs, to enhance our mesh analysis, circuit analysis solution via the Matrices method. Okay, all right, let's write here. Dolphy Gilpin is the name. And this is now one of the application of the PDA methodology and the metrical outputs. And so let's suppose that we have a general electrical electronic circuit, and here we have the elements. And let's say this was 10 ohms. We call this resistance 1. This is voltage 1. And we say this is 10 volts. However, current moving so in a clockwise direction. We assume it moved in a clockwise direction here, or rather, current always move from positive to negative. Electrons move from negative to positive, and current flows from positive to negative. And we have now 40 ohms here, and we call this current I3, I1, $20 ohms here, 20 volts here, and this is now V2. Can't move from positive to negative, so this is now I2. So this is how we call it. Is equal to I1 plus I2, I3 equal to I1 plus I2 here. All right, and if we use the mesh analysis method now, what we have now is that the 10 volts, V is equal to Ri. We're saying that 10 volts equals down to 50 I minus 40 I3, and that now minus 20 is equal to minus 40 I1 plus 60 I2. Or know that the voltage is equal to R I whatever 50 minus 40 minus 40 60 multiply now by I1 I2 is equal now to 10 minus 20. Now we're assuming now that these parameters, pay parameters, are coming from our PDM output analysis. Remember, we worked down to a 2x2 matrix, and so these parameters, these dual pair numericals, and what we say now is that I be equal to V over R, or that numerical wise we see now that the inverse R1 multiplied by V. So this will be the inverse transform matrix. And we see now the inverse of R will be equal now to 60, 40, 40, 50. So if we do the determinant now, what you have now is that R (60) multiplied by 50, and 60 50 minus now 40 multiplied by 40 that will be equal to 1,400 volts. And that will be equal to 1,400. Or know that R minus 1 would be equal to 1.4 1400 into 60, 40, 40, 50. In that case, now I1 would be equal now to minus 0.143 amps. And I2 would be equal to minus 0.429 amps. So if we have numerous 2x2s, and if we use these paired dual magnitude parameters, and we set it up in our matrix mesh analysis method, then we could solve for voltages, current, and resistance via the, the mesh analysis or circuit analysis via the matrices method. So let's do one more. And let's take a break before we move on to another circuit analysis problem.